So Internet of Things is all about interacting with the physical world. So as we get into this, it's important for you to understand how to interact with physical systems. And we're going to start talking about things like wiring and enclosures and how to deal with the mechanics of IoT. So as some review, I'm going to talk a little bit about electrical current. So as you'll recall, electrical current is about electrons moving within materials. So if you have a material with electrons in it, you can apply a force to those electrons, and it'll cause those electrons to move down the material. And we call this current. So when we talk about current flowing through materials, there's different kinds of materials, and some materials are more amenable to current flow than others. In particular, if you could kind of take a material and look at it in detail, what you would find is that there's a bunch of atoms, and then there's places where electrons can be. And in some materials, if you apply a certain amount of force, you can kind of get electrons in there. And then if you apply more force, you can get those electrons to move. And often these different levels of energy that you apply to these materials can be separated. So if you have a material, there's a certain amount of force you can put in, or electron energy you can put into the material that can get electrons in there. And that's called the valence band. That's like a band of energies where you can get electrons into the material. There's also another band called the conduction band, which is where electrons actually move. So in certain materials like metal, these two bands overlap. There's a region where you can kind of get electrons in there and they can kind of move easily. So in metal, we can move electrons easily, and then we call these conductors because they're very good at conducting electricity. In other materials like insulators, these bands are separated. So you can kind of get electrons in there, but then there's a huge step you have to do to kind of really push those electrons to get them to move. There's a band gap. And so insulators are not good conductors. You can kind of get electrons in there, but it's really hard for them to move. And then in between there's semiconductors where these bands are close, but it's kind of hard to get electrons to kind of cross this gap unless you dope it. So we can talk about conductors and insulators. And when you're building something, when you're building a device, you got to think about where you want electricity to go. You might have wires going around where you want electricity to go in certain directions. You may have physical enclosures where you want to prevent electricity from getting in. You want to insulate your device from static or lightning and other effects. So it's helpful to know the properties of different materials and how well they conduct and how well they insulate when you're building devices. So in particular, if you have a material, it could be a conductor. A conductor is a material in which your valence electrons wander around easily. It's good at conducting energy. There's also insulators, where your valence electrons are tightly bound to your nucleus. So it's hard to move electrons through them. And then there's semiconductors, which are in between. So if you're building something where you want to carry electrons easily, use a conductor. So materials like copper and aluminum are good conductors. These are used for things like carrying signal and cables, transferring electricity. Insulators are used where you want to kind of separate conductors. So if you want to take a conductor, but you don't want it to touch another conductor, you can wrap it in an insulator. And for this, use things like glass and latex and plastic and rubber. And then there's semiconductors. Semiconductors are what we use to build electronic components like integrated circuits. Semiconductors are things where you can easily make them more conductive by adding impurities. So to get a sense of how different these materials are, let me show you some real numbers. So as you can see from this chart, if we have something like glass, glass is an insulator. Glass has a really high resistivity. You can push electrons in it, but you're going to need a lot of force to get them in there. Very high resistivity. Same for mica and quartz. Very high resistance to electricity. Something like copper is totally opposite. Very easy to slide electrons through it. Okay, so conductors and insulators are different. Now the next question is, if you're building something and you want to conduct electricity, you want to use wires, what specific kind of material should you use? So it turns out there's a lot of different metals, and knowing the properties of these different metals can help you make more intelligent decisions about your designs, because you'll know what kind of wires to use in your particular environment, because they're actually very different. So as one option, we have copper. Copper is used all over the place. Copper is a great material. It's cheap. It has lower strength. And if you've ever taken a piece of copper, like a copper wire, and tried to bend it, it's very easy to bend it. It has low strength. It's also subject to melting. It has a somewhat low operating temperature. It's also subject to corrosion. So if you leave it out and it's exposed to oxygen, it'll turn green. I don't know if you've ever seen the Statue of Liberty. That thing's made out of copper, but what happened is it oxidized and it turned green. We're used to that. We probably could scrape all that stuff off. The same thing happens with regular copper wires as well. If they're not coated, if they're exposed to oxygen, they'll oxidize. And that can make problems when you're forming connections between them. It's subject to corrosion from air and also water. It's better at conducting heat than other materials though. So that's why we make pans out of copper sometimes, because you put it on a burner and it'll conduct the heat all over the pan, so that's nice. So if you're building a material, you're building a device, it's got a CPU in it, the CPU is getting hot, you might want to put copper on top of it because it'll conduct the heat away from that, which is nice. However, it's worse at radiating the heat. It's good at kind of absorbing heat and kind of spreading it around, but it's not good at radiating it because it's a pretty dense material. So copper is really good for wiring. We use it all over the place for wiring. It's also good for flexible parts. If you want to build a wire and the wire's in an environment where it might kind of get bent, might interact with humans, or might kind of move around, copper is a good choice for that. Another very common conductor is called aluminum. Aluminum is less conductive than copper. So if you're building wires, it might be better to use copper wires than aluminum wires. Aluminum also has problems handling load surges. It has some other problems too. Back in the 1970s, there was a shortage of copper. And so for a period of time in the United States, we actually built house wiring out of aluminum. And that worked great for a while. And then people started noticing there were a lot of fires in these houses. And the problem that happened is that aluminum is not as malleable as copper. If you have two pieces of copper, like two copper wires, and you kind of twist them together to form a connection, copper squishes together, which works really nice for connections. If you have two aluminum wires and you do that, they don't really squish together very well. They're not as squishy. And this led to fires because you'd have these little gaps and sparks would jump across them. So these are some issues with using aluminum. However, aluminum has some great advantages too. It's one of the most lightweight metals. So if you want to build physical enclosures, something that can protect your device and it's strong, but it's also very light, you want to use aluminum. It also has less corrosion than copper, so it can resist the elements. So all these things make it really good for cases, and corrosion-resistant wiring and pipes and foils and things like that. It's also a great choice for heat sinks. A lot of heat sinks are made out of aluminum because it's not all that great at kind of distributing heat. It's good at radiating it off because it's not very dense. So aluminum is a good choice for these sorts of environments. Another choice for a conductor is silver. So of all the metals, silver is the best electrical conductor. It's very good at conducting electricity, very low resistance. So if you're dealing with environments where you're very battery constrained and you need to transmit electricity, silver is a great choice for that. Silver also happens to be the best thermal conductor as well. So if you have something that's hot and you need to get the heat away from that, you can use silver. Silver has a high melting temperature, so it can withstand high temperatures. Unfortunately, it's very expensive. There's a lot of demand for silver, and there's not much of it, so that drives the prices up high. Still, it's good for environments where you're building things and you're deploying things and you can afford to pay high prices. Silver also has poor corrosion properties. I don't know if you've ever been in a house where someone owns silverware, but that stuff tarnishes. You kind of have something that's nice and shiny, and over time it'll kind of get cloudy. You need to polish it. That's corrosion. Not very good for electrical connections. You have two pieces of silver pointing at each other. That stuff can get in between and damage the connection. So you have to maintain it. However, silver is very reflective. So it's good for things like mirrors and optical components. It's used a lot in optical storage and optical mechanisms. It's also very pliable, and it's very ductile as well. So it's good for if you're building very, very thin wires. It's something you can kind of stretch out, make very, very thin things. If you're building intricate things, silver is a great choice for that as well, because you can take the silver and kind of pull out little tiny things. If you're doing something with steel, that's much harder to do because steel is brittle and steel breaks. But silver is great at that. Another choice is nickel. So nickel is a metal that's very corrosion resistant. It's very strong. and it has a very high melting point. So if you need a material that's very resistant to heat and it's not going to melt, if you're dealing with really hot industrial environments, nickel is a great choice for that. Unfortunately, nickel likes to interact with other metals, which is good if you're trying to form alloys. If you want to mix nickel together with other metals, that's a good thing. But it's a problem if you kind of have a plate of nickel and you have some aluminum pressed up against it. It's kind of sitting there. Those metals will interact with each other, and it'll form a new metal that on the boundary between them, which is not conductive. So there's problems like that can happen. Nickel is very catalytic. It likes to interact with other things. Nickel is very ductile though, so it's good for intricate components. And nickel has a high resistance to electricity and heat. So it's not something where it's very conductive. But if you have situations where you can kind of use a little extra battery to push electricity through, then nickel can be a good choice. Another option is to use tin. So tin is a very soft metal. Tin is something, I don't know if you've ever held a tin can, but you can kind of squish it. You know, it's metal where you can kind of bend it pretty easily. It's very soft, it's very malleable and ductile. It has a pretty good durability though. So like if you have a tin can, you can kind of squish it over and over, it's not going to break very easily. So it is strong. It has poor corrosion resistance to acids and also very basic materials, alkalis. It'll corrode a lot in those environments. However, for water, it's great. Tin doesn't corrode much in water, so tin's very good for marine applications. If you're building something that's going to sit next to water, you know, in lakes or oceans. Tin also has a very low melting point. So if you want something that can kind of melt and be malleable and you can work with it at low temperatures, tin is a good choice. And actually tin is used a lot in solder to create connections between electrical conductors because it's very malleable. It's used for malleable enclosures. If you want to build something that encloses your system, you know, a case, and you want to, you know, it's not good to build very rigid things because rigid things break. So tin can be a good choice if you're dealing with an environment where it might get knocked around. You want to have a little flex in it. Tin's a good choice for that. I also want to mention steel. So steel is actually a very poor choice for a conductor. It has very poor electrical conductivity. We don't really use steel wires to conduct electricity if we can avoid it. It also has poor thermal conductivity, not something you want to use for heat sinks. However, steel is really strong. We use it to build skyscrapers. Very powerful, very strong and heavy. Steel is also something where it's hard to create shapes out of it because it's very brittle. It's strong, but if you try and bend it, it'll resist bending, and then it'll just break. So if you want to kind of build shapes out of it or intricate designs, really hard to do that with steel. Steel is also subject to rust and corrosion when it's exposed to water. If you want to prevent this sort of corrosion, you can coat steel. You can coat it in a plastic. But if it's exposed to water, it'll corrode. So steel is what you want to use if you want to make your device strong. It's good for building reinforcing infrastructures. If you have struts or cables or enclosures, steel can be a good choice for that. So what I've done here is I've kind of given you an overview of the different kinds of conductors you can use in your design, different kinds of metals. So if you're going to choose which wires you're going to use in your design, you now know a little bit more about the different properties of these metals. You can choose between these for your wires, your enclosures, and so on.